Let's build and train a neural network. Now, we will show how to use TensorFlow to build a model that identifies the language of a given text. As a professional data scientist, a key point is to find the proper data to achieve your goal. In that case, if we want to build a language recognizer, what else than Wikipedia can be better for us? As usually, Python does not leave us alone and provides a great package called Wikipedia. What we did is randomly pick the summary of Wikipedia pages from 4 languages: English, Spanish, French, and Italian. At the end of the notebook, we will use this code again to get a test set for our final prediction in order to evaluate our model on brand new data extracted in real time. Before starting, we will ask you a text processing question. In that specific case, would you remove stop words? Well, the answer is no. They do define a language, so we need them. Okay, now we have the data. How do we build a language classifier? What are the steps to build a model in TensorFlow? First of all, text processing, as described in the previous slides. Then, define the neural network architecture. Then, train the model. And finally, evaluate the model. What is the proper neural network architecture for our purposes then? The typical and simplest architecture for a text classifier is the following. First of all, an embedding layer that will map our words into an embedding space. Then, a flattened layer that prepares the output of our embedding for the final layer, that is, the dense layer, that will output 4 probabilities, 1 for each language. Let's implement our first TensorFlow text classifier. As usual, we start loading the packages that we will use in our notebook. And here we have the dataset we extracted from Wikipedia. We have a sentence and a language. Let's print the length. Not a big one, but sufficient. Now we have a key step, that is to label and code the target variable from text to number. Here we have a text, we want a number. And obviously, the number of classes equals to the number of languages. As we mentioned in the slides, we will perform the previous text processing steps except for stop word removal. Here we set the maximum number of words to 5,000 and the maximum sequence length to 400. We tokenize and then fit on text. And this number represents the number of words that we tokenize. That is different from max features, but necessary for the definition of the dimension of the embedding space. We will explain in the next section why we add 1. Then we create sequences and pad, and then we divide the train and test. This is the final dimension of the embedding space, and then let's write down the model. We have a first embedding, which is a layer embedding, we have the second layer, which is a flattened layer, and then we have the output layer, which is a dense layer with 4 probabilities, 1 for each language. Here we also define the final activation function, which is the softmax function, typical for multi-class classification problems. We define this loss function and this matrix, and then compile. Here we show the architecture of the model. And then, finally, we fit it on 3 epochs. Remember the train and test split? Now we use it to evaluate our model. Well, it looks like we have an almost perfect model. Let's take a look at the confusion matrix. We import this package from sklearn, and then we make the prediction on the evaluation test. Here we generate the confusion matrix, and let's see what do we get. Perfect, really perfect. Okay, now we continue with new experiments on brand new text. In this video, we just built a model that is capable to recognize a language given text. In the next video, we will make some experiments on brand new text to see if our model is robust. Let's predict and evaluate the outcome.